Behold the rainbow, a divine promise of real life. Share and lightness explosions will follow. Comment and be heard.
Real-life examples of electron flow. Static electricity. Rubbing balloon on hair transfers electrons.
An electron is a tiny subatomic particle that carries electric charge. Each electron carries a negative electric charge equal to the charge is equal to the number of electrons multiplied by the charge of one electron. This shows how charge builds up from individual electrons. Q equals N times E, where Q is total charge in coulombs. N is the charge of one electron. If a body gains 10 to the 12 electrons, Q equals 10 to the 12 times negatives of -9 charge. Q equals negative 1.6 times 10 to the negative 7 coulombs. So electrons are the carriers of negative charge. What is electric change? Electric charge is a property of matter that causes electric forces and electric fields. Two types of charges exist: positive charge, or protons, and negative charge, or electrons. Like charges repel. Unlike charges attract. Electrons carry charge, and voltage pushes those electrons through conductors to produce electric current. Electrons flow when there is a difference in electric potential or voltage, called the electric pressure. A battery creates voltage. Voltage creates an electric field in the wire. The electric field pushes free electrons. Electrons drift through the conductor. Voltage creates an electric field within the wire. This motion is called electric current. When you connect a battery to a bulb, the battery creates an electric field. This field makes an electric current flow, illuminating the bulb. The wire provides a path for electrons. Electrons move through the wire. The bulb lights due to energy transfer. Physically, electrons move in a metal conductor. Conceptually, we say electric charge flows because charge is carried by electrons. In a real battery, electrons flow from the negative to the positive terminal, but conventional current is defined as flowing from positive to negative. Why the difference? When electricity was first studied, scientists did not know electrons existed. They assumed positive charge was moving, so the conventional current direction remained in physics and engineering. In a real-life battery, electrons flow from the negative to the positive terminal, but conventional current is defined as moving from positive to negative. Electric current is the rate of flow of charge. It is measured and defined as coulombs per second. Like a river, charge flows through a wire. In a real-life example, if 5 coulombs of charge flow in 2 seconds, the current is 2.5 amperes. In a thunderstorm, positive and negative charges separate in the clouds, creating an electric charge difference. In real life, electric potential is the energy per charge creating aura. Here, a power charge raising the traction. In a storm, a massive charge difference between clouds and ground creates lightning. This powers electric circuits, where electrons move through wires to light up our devices. In a simple electric circuit, electrons move through wires, powering devices like this resistor and these meters. Electrons move through wires, powering devices. In real life, within every computer, a vast multitude of electrons moves at incredible speed through tiny transistor pathways.